Good morning, everyone. Welcome back to the hall. If I may invite the speakers to the stage, please. Caroline, Martin, and Munish, please. And I will invite the panelists once the presentations are over. So if Rui and Matthew can also be, oh, you're here? Okay, great. Excellent. Okay, so can we get started? Okay, great. So welcome again. This is the session on small cell Open RAN technology strategies. And again, a very hot topic. And we have an excellent set of speakers here who are going to share their insights with us. We'll start with Caroline, who will talk about a more in-depth look into the Open RAN small cell market. And we'll follow with Martin from Picocom, who will talk about the implementation of Open RAN solutions, but with an element of flexibility in it. And then Munish, who is going to be, unfortunately, Ganesh, whose name is on the agenda, is not able to be here. So Munish will be talking from Radisys. And he's going to talk about the future of Open RAN. So they call it Open RAN Plus, I think, in Radisys, right? Okay. So without further delay, I'd like to invite Caroline.
Thanks, Prabhakar. Probably everyone knows who I am by now because I've been on the stage quite a lot in the last couple of days, but anyway, in case not, I'm Caroline Gabriel and I am a co-founder of Rethink Technology Research. I'm also a research director at Analysys Mason and content director of the Small Cell Forum. And yesterday I shared some highlights from this year's edition of the annual operator survey that we carry out each year for the forum and which feeds into our market status and forecast report, and that will be published in a few weeks' time. And this year we had a very good response to it. We had inputs from 78 mobile operators and 42 other deployers of small cells, who include private network operators, neutral hosts, and so on. And of course, this year, vRAN and Open RAN are very hot topics in the survey and our discussions with the operators. So we thought it would be good to set the scene for this particular session by drilling down into some of the results that we saw this year. And again, when we publish the full report, there'll be a lot more detail, a lot more breakdowns by regions and so on. This is just to give you a flavor and hopefully some ideas for discussion on the panel later on. I think one of the key themes of this conference is that is diversification. That 5G is going to be used for all kinds of use cases, particularly in enterprises. That means that one size of network and deployment model certainly doesn't fit all anymore. We can see that for different use cases, applications, deployment environments, we need many form factors and many price points. Some scenarios are very price sensitive. In others, there's a significant budget because the network is mission critical. So again, this isn't necessarily, when we talk about Open RAN and diversifying the supply chain, we're not necessarily talking about driving down costs. We're talking about having a bigger variety of price points, including simpler, smaller designs of small cells, which can suit scenarios where perhaps the major vendors wouldn't find it profitable to support that kind of architecture. Doesn't mean everything is becoming cheap, and I think that's often a bit of a misconception in Open RAN. So this is all about diversity. We need a wide ecosystem of vendors to deliver all those different form factors and variations, and a wide ecosystem of operators and deployers. And we're seeing new entrants to the value chain on both sides. And a lot of this is being triggered by enterprise and industrial deployment, and in turn by 5G standalone. The majority of enterprise deployments, unlike public and macro networks, are standalone. And a lot of the innovation that we're seeing in 5G standalone, as it just starts to sort of hit the mainstream in 2022, a lot of the initial innovation is being done in the small cell environment. And I showed this yesterday, but I think it's worth looking at it just one more time because it sets the scene for the overall idea of having a more open architecture and value chain. So this is our tracking of standalone, 5G standalone networks deployed so far as of May, and we saw 74 in small cells and 21 in macro. That's not surprising in itself. What is more interesting is the percentages in the middle bar that are being supplied by either new vendors or multi-vendor architectures, and 24% of the 5G standalone networks in enterprise tick those boxes. So this, of course, is very relevant for the Open RAN discussion. And also on the deployment side, 47% have been deployed by private network operators or neutral hosts, compared to predictably very few on the macro side. So the whole value chain is opening up of necessity to meet the very varied requirements of different enterprises and use cases. And that in turn drives this rising interest in open, disaggregated architectures. And again, the real-world deployment is being heavily driven by small cells because it is somewhat quicker and easier to apply a complex new architecture in a network that has a fairly limited geography and doesn't have quite the traffic demands of a big macro network. So while, as other speakers have commented, a lot of operators don't think they'll get to full disaggregated Open RAN in the macro until the late 2020s, in small cells the progress will be much quicker because there are slightly lower barriers to jump. And so this forecast, this is part of our forecast. It's showing enterprise small cell deployments up to 2026. These are subsets of each other, to be clear. So the blue line is vRAN, any vRAN, including closed architectures. That will make up about 78% of deployments by 2026. Huge majority of those will be Open RAN, 71% of the total by our forecast. So what are the drivers of this? I think when we look at a lot of the conversation around Open RAN relates to the public networks and the big 5G networks. It's very political and it tends to be very much driven by the need to diversify the supply chain. Clearly that's important in small cells, but to an extent the small cell industry has always been more diverse and has had lower barriers to alternative vendors and smaller suppliers, and we've seen a lot of them talking and winning awards in the conference. So in the enterprise, really the drivers are less about the politics of supplier diversity and more about enabling 5G standalone networks that, as I say, can meet a vast variety and a growing variety of different use cases, particularly in the enterprise. But deployers have other drivers as well to move towards a more open RAN architecture in small cells. The graph shows the top three. We asked all the respondents to the survey to initially to give us a long list of all their drivers for interest in Open RAN. And then among the top 10 or so, we asked them to select three that were most important to them. The top level results of that you can see here, and it's split between the tier 1, tier 2s, which are basically the mobile operators, and what we call the alternative deployers. The priorities are similar, except that there are a few things like simplifying rip and replace that are clearly much more relevant to the MNOs, who have the bigger installed base at the minute, even in enterprise. But generally, what's coming out first is to reduce the total cost of ownership, not just the cost of the equipment, but the cost of operating the networks, deploying them, maintaining them, and so on. That there's the sense that if you have a much wider choice of vendors and supply chain, there will be more innovation in how to optimize the cost. And that's followed by 40% of the alternative deployers prioritised stimulating more innovation. They believe that open architectures, and particularly the cooperation on specifications, will provide a much wider base of innovation into which they can draw to get the best solution for their particular requirement. And access to the broader supply chain, that comes third, along with multi-vendor interoperability for both categories of operator. But of course there are barriers, and Open RAN is probably at the point where we hear, of peak hype, where we haven't heard too much of that, to be fair, in this conference, but in the broader world we hear an awful lot of talk about Open RAN as though it's going to solve every problem that the industry, or perhaps in some cases the entire world, has got. And of course we've all heard these sort of messages before about new technologies, but the fact is there are very significant barriers to deploying Open RAN. If you think of Open RAN as a multi-vendor disaggregated network, there are simple Open RANs. You can deploy a non-disaggregated network where the radio units and the basebands all come from the same vendor, but you've got a compliant open front haul. In theory, one day you can swap out one of those pieces. That's fine and that's easy, and a lot of the early Open RANs are actually using that architecture. But here we're talking about pushing the architecture to its limit of being fully disaggregated and potentially with several vendors in one network. So what are the barriers to this? The one, and again we asked the panel for their top three from a short list. The one that comes out very strongly above any others, and this is true of every sort of network and every sort of deployer, is the risk of increased cost and complexity from having to integrate multiple vendors. And we've heard about it from some of the speakers in the earlier session, and I'm sure we'll hear some more now. If one of the drivers is to reduce TCO, adding a whole layer of integration, whether that's done by the vendors or by a third-party SI, is obviously putting in a new element of cost, which deeply concerns most companies who are looking at Open RAN. After that, some of the other ones that came out very important were immaturity of the technology and supply chain. That's inevitable with anything that's new, of course. And another very important one is, are there performance trade-offs compared to an integrated RAN? This very much depends who you talk to within an operator or deployer as to how sort of cloud-focused they are as opposed to radio-focused. But inevitably a new architecture will come with some trade-offs compared to an integrated network that was designed for one purpose only and is fully optimized for that purpose. So there are many other barriers here. Most of them, I think it's fair to say that the ecosystem is well aware of them, that the vendors are working very hard to try to reduce the risk and allay the fears, but these will have to be addressed before Open RAN is really being pushed out at scale in its full disaggregated form. So one of the issues, one of the risks that deployers see, of course, is, well, which of the architecture choices do we go for? And Doug's keynote set out really clearly the main options, but also showed some of the complexity. There isn't a right answer for nearly any scenario. This is what our respondents think they are going to deploy or support in terms of the main functional splits that we've focused on at this event. So 2, 6, the ORAN split 7, and then split 8 and other implementations of split 7, because obviously ORAN's only one of those. You can see that the yellow bars are what they expect to do in the fairly near term, up to the end of 2023, and the purple bar is between 2024 and 26. It's important to say that when you ask people what they expect to support in an architecture that has only just been defined and is, where there are all kinds of uncertainties, this is almost certainly not going to come true. This is an indicator of what companies are currently thinking. I think as things become clearer, they will probably start to narrow down the number of splits that they would expect to support. Because as you can see, these figures don't add up to 100. Most companies, and we'll see a bit more of it later, expect to support different splits in different scenarios. And of course, a lot of operators are building multiple networks in 5G. I mean, Deutsche Telekom is a great example. They've got private networks, they're big macro networks, they've got industrial networks, all of them separate, all of them potentially using different architectures to fit those different scenarios. But I suppose the important thing to note here is at the moment, the very, very high preponderance of support behind 6 and 7 as opposed to the other splits. And all this is very closely tied to the availability of spectrum. And of course, that adds another complexity, as Doug also touched on, when millimetre wave comes into the equation, for instance, and massive MIMO, a whole new range of challenges is introduced to the implementation of an Open RAN. But however, as we talked about yesterday, and I showed this slide before, a lot of the new deployment models will be supported by access to spectrum that is not licensed and controlled by the mobile operators. And you can see in this is our forecast of enterprise small cells by licensed versus unlicensed or shared or local spectrum. And we see that by the end of 2024, these are about equal. And then after that, the weight is towards the new flexible spectrum. And by 2026, we expect over about 55, 56% of deployments to take place in those new types of spectrum. And that will be a big driver for Open RAN. But we shouldn't just talk about the RAN. The other problem I sometimes have with the Open RAN conversation is that it is so RAN focused. And yet, if you talk to most operators, and particularly those looking at enterprise environments, the maximum flexibility and return on investment in their networks is going to come from an end-to-end planning, looking at the network in a holistic way. So just this slide, I'm venturing into the packet core, just to make this point that the benefits of an open architecture will generally be maximized if the core and the RAN are considered together. And in some ways, the multi-vendor approach and certainly the virtualized approach to the network has clearly been pioneered in the core. There's a lot of virtualized and some multi-vendor 4G packet cores, which is by contrast with the RAN. The core is easier to do, it's for sure, it's much more software oriented. But you can see that there are lots of different approaches expected to be taken to the core as well. And this again is referring to enterprise small cells. The main approaches are to distribute out the user plane functions, so separating the control and user planes, becoming increasingly important. You can see 16% expect to do that in this year or the near future. That rises to nearly 30% by 2026. And that's the key difference, is like the RAN, the core will become increasingly distributed, particularly in the user plane. And both of these domains will become increasingly integrated with edge compute in the enterprise, whether that's public or whether that's on the enterprise premise. And you can see the black line is showing the percentage of core network functions that will be running on a piece of edge compute within the network, getting to about 2/3 in 2026. Those edge nodes may well also be running some of the RAN functions, even some of the virtualized transport functions. And this is where you start to get the real efficiencies and some of the total cost of ownership and agility benefits that operators want, is to put everything on the same infrastructure and use that infrastructure for enterprise applications as well. We heard some of that from EdgeQ and others today, but we see that the operators see this as extremely important in how they're planning their open networks going forward. So let's not get too hung up on the RAN as something that is standalone, outside of the 5G standalone meaning of that, of course. So my final slide is, within all this change and all this uncertainty and all these evolving architectures, there is a very serious risk of fragmentation between different decisions about the architecture, different bodies who are specifying it, and so on. So common foundations are essential. We talked about this yesterday, and it's been a theme in a lot of what we've discussed in the event, that there needs to be some common foundational specifications, and they need to be at every layer. As speakers on the last panel said, this isn't just cross-haul. This is, having open interfaces for the RF front end or between components on a system on chip. So the interfaces need to be everywhere, and they need to be commonly accepted. And of course, the work that Small Cell Forum is doing with Open6 and FAPI and others is very, very important example of that. But however, common foundations must not be a straitjacket. One of the common criticisms of Open RAN, and particularly O-RAN in this context, from operators is that it's too prescriptive and it's trying to push people down one interface when actually they want the flexibility. Ideally, a software-defined interface, although we heard earlier Doug explained why that's something that's probably not going to happen tomorrow. But really, the sort of flexibility to choose and to change, because some of the use cases that will be in use by 2027 are not even really properly envisaged yet. So for now, operators are very firmly trying to keep their options open, and you can see on the list, on the left, this is the percentage of our respondents who plan to support different numbers of functional splits in an Open RAN. And some of this does depend, as I said, who you talk to. I mean, you talk to the radio engineers, and they would, ideally want a split where most of the functions close to the radio are very hardwired and not so keen on these very disaggregated ones. But you talk to the cloud engineers within operators, and of course they see the agility and the scale that a cloud network can give you. So you'll get different responses from different departments, and it will be important for a challenge for the operators to try to bring those people together in a consensus that delivers the optimum combination of functionalities. But at the minute, we're seeing 30% of operators and deployers expect to support 2 split options, and a huge 44% expect to have 3 in different parts of their various networks. And it's not just architectural splits. Just a very quick note to mention Wi-Fi, which of course is incumbent in so many enterprise situations. This is the other source of openness where the industry needs to look at different open networks and how they work together. So we can see here on the right, this is the combination of different radio access technologies that companies and their deployers expect to support. And you can see 44% would like by 2026 to have their Wi-Fi and their cellular integrated. And that's a whole new challenge, I think, for open network architectures going forward. I hope that's some food for thought, and I will hand back to Rebecca.
I love the last slide where you said that, common foundation shouldn't be a straitjacket, especially in the early stages of 5G. I think there's a lot of wisdom in that. Thank you. And I don't know if you noticed, but I was trying to politely stand up to indicate that there's only 1 minute left. So I hope it was subtle enough. But this is also an indication to Munish as to how I want to communicate. So let's invite, and Martin, of course. So let's invite Martin from Picocom. He's going to talk about how to implement Open RAN small cells with flexibility. Thank you, Martin.
Thank you. Yes, so I'm going to talk about how we build small cells suitable for Open RAN deployment. So the first thing I want to say is a significant part of the slides I'm going to show are based on some work we did in Small Cell Forum, SCF 251, which was it was an FR1 reference design paper. So we set out to define an architecture for a small cell, define functional entities, define interfaces, so that different component vendors can be interoperable within the small cell and create a range of solutions. It's not a straitjacket, but it's a framework for building small cells. Contributors to the paper are analog devices, Icana, Picocom, Senko, and there's plenty of material on it. The paper can be downloaded from SCF, but we also are a cover feature in Microwave Journal, May 2022. And last week we were involved in a podcast, so the 4 companies contributed to that. So the agenda, very briefly, 5G small cell drivers. So what's driving this the contribution that I'll be presenting? A very quick overview of a 5G small cell architecture. And then I'll be focusing on dimensions of flexibility, and 3 particular dimensions being spectrum, performance, and functional split. 5G small cell drivers. So I think most of the people in the room understand these drivers. Network densification, private networks, edge compute, neutral host, which I flag on this slide as being an interesting use case, and that very much drives the architectural decisions that we make. And of course, the other driver, open multi-vendor ecosystem. So small cell architecture, we've seen lots of slides showing the various splits, so I won't go into that in detail. What I will say is that in the context of the SCF 251 reference design, we identified the RU as a small cell radio unit and the combination of DU and RU as a small cell distributed radio unit. So, dimensions of flexibility. First dimension, and there's many more I could have listed, lots of dimensions here, but time is limited. So first dimension is spectrum. So we have a multitude of bands. We have the total bandwidth that we're going to support from a single small cell radio. We've got the matter of supporting 4G and 5G services and doing that dynamically. And spectrum also brings with it the question of duplexing. Is the spectrum FDD or TDD? That makes a quite significant impact on the hardware design. We then have performance, so loosely speaking, throughput and transmission powers. And then we have functional split, so I'll be talking about splits 2, 6, 7.2, and the possibility and trade-offs associated with a software-defined split. So I'm going to introduce a diagram here, and this is a diagram that I'll be using throughout the presentation, and I'll be using it to exemplify where flexibility impacts the design of a small cell. So this is one of the diagrams we produced for the SCF 251 reference design paper. We identify functional blocks and we define interfaces. Each of the interfaces is listed in this diagram. So just going through them in turn, we have interfaces and power. Much of this is use case dependent and optional, so GNSS receiver may or may not be included in a small cell. What is needed is a front haul or mid haul interface, which would be terminating split 2 F1 or split 6 NFAPI or split 7.2 eCPRI. In the paper, we identify Ethernet as a key technology for implementing that interface. We then have a baseband function, which is all of the digital processing necessary to run the stack, if the stack is included in the small cell, and run all of the physical layer operations. So there's signal processing in there, there's software, there's processors. There's probably tens or hundreds of processors in that baseband subsystem. Then on the right-hand side, we have the RF transceiver function. We identify there are a number of vendors in this space, and in the context of this paper, ADI were the experts in this field and bring a solution into this reference design. We identify for the interface between the physical layer and the RFIC, JSD 204 as an industry standard. It's supported by multiple RFIC vendors and multiple baseband vendors. So we heard HQ talking about that in this morning's session. I've added an additional box to this diagram over and above the diagram in the SCF 251 paper, and that's specifically the DFE function. And that's to link this presentation into other work that we do in Small Cell Forum in defining control interfaces. So there is a function in a small cell called a digital front end. It handles things like digital filtering, up and down conversion, digital pre-distortion, crest factor reduction. And in the context of Small Cell Forum, we have standardized the control aspects of the DFE in the FAPI P19 specification that we produce. In the RF transceiver section, there's the option for having one or multiple RFICs, depending on the scale of the small cell. And architecturally, there's little reason why there couldn't be 2, 3 RFICs. Over on the right-hand side, then, we have the RF front end, which is essentially power amplifiers, low noise amplifiers, RF filters, and some calibration circuitry and logic. There's an interface U4 shown, which is essentially, it's an RF interface, so it's an analog RF interface. And in the paper, we did consider whether U4 would be a modular plug-in interface. It very likely could be. I think Pete mentioned it in the panel session. In early days and in certain scenarios, interchangeability of RF front ends may be beneficial. But when it comes to high volume deployments, it's extremely likely that all of this is integrated onto a single printed circuit board. And then right over on the right-hand side, we have the antennas. Okay, so first dimension of flexibility, spectrum. And this is typified by the neutral host case, which can be multi-carrier, multi-band, mixed duplex, and 4G, 5G. So how does this affect the architecture? Well, the baseband should be and is fully flexible, so spectrum shouldn't really matter to the baseband. Also, the current generation of RFICs typically tune from some hundreds of megahertz up to 6 gigahertz, and similarly are not particularly impacted by spectrum that they're going to be deployed in. They're wideband and they're modulation agnostic. The main point of pain is in the RF front end, over on the right-hand side. So I'm showing a very busy slide now. Now I was very pleased to see that Ofcom have created a summary slide showing UK MNO spectrum from 700 megahertz up to 4.2 gigahertz. All of the bands are labeled. There's a whole load of legacy stuff on the left-hand side. Over on the right-hand side, we have new spectrum that's been made available. And we see opportunities for small cells to operate across all of these spaces. But having said that, you know, the real interesting stuff is over on the right-hand side, band 42, 43, or N77, where we have a sizable 400 megahertz chunk, which in the UK is occupied by all carriers. So it would be ideal if a single SKU of small cell could serve N77 or select parts of N77 that provided full 4 MNO support. So in terms of drivers for making that happen, on the RF front end, a single SKU, 400 megahertz TDD would be needed to do that. That's viable, and it's laudable to build such a thing. In the case of the others, the other bands, it gets a little more complicated. We have FDD cases in there. There's also less spectrum down in those low frequencies. And if we were taking, for example, indoor use cases, it's really the N77 that has difficulty getting from outdoor to indoor, and that's really where the drive for indoor deployment should be moving forward. So next dimension of flexibility is performance, and performance being throughput and transmission power. I'll start with throughput, because there is a lot of flexibility in modern systems. And so throughput can be characterized in terms of the total bandwidth that's supported by the baseband. And this is largely constrained by the amount of processing power that the baseband has. So I'd say constrained by gigaflops, but pick any measure of performance of baseband. And so for the baseband, we dimension this across the design for all of the use cases we want to address. We trade off bandwidth and multi-band operation. So as an example, a baseband may have the ability to support a total of 800 megahertz on one antenna, 400 megahertz on two antennas, 200 megahertz on four antennas, and 100 megahertz on 8 antennas. How do we want to cut that? There are single band options, so we could have single band 8T8R, single band 4T4R with dual carrier aggregation, dual band 4T4R, or potentially even quad band 2T2R, or any combinations above. And that is largely a function of the baseband. The second element of performance is transmission power. Now, in the old days, this would have been a huge differentiator. It largely affects the RF front end, and in the RF front end, it is a big differentiator. It's less a differentiator now than it might have been in the old days, and the reason for that is because of digital pre-distortion. So DPD is pretty much universally implemented in either baseband or RF transceiver these days. And the result is that RF front-end designs can be nonlinear, get linearized, and even low power amplifiers these days are nonlinear and are designed with pairing with DPD in mind. So transmission power is relatively straightforward to contain within the RF front end, relatively little impact on the rest of the design. And then the final dimension of flexibility that I'm going to talk about is functional splits. So this leads on from a question that Simon Fletcher asked Doug. And we've seen lots of presentations with functional splits described. And the question of whether a software-defined functional split is possible in a design came up this morning, and it's come up before. So the question is, can this be supported? The answer is yes, it can. And we have stand outside, and we have a demonstrator, which is our small cell board. And in principle, it's capable of supporting split 2, split 6, split 7.2. All of the components are on there to make that happen. It's constrained by the total processing power available in the unit, and it's constrained by the microarchitecture. So for example, if that baseband was pure software, so a general purpose processor, then software-defined splits would be eminently feasible. But of course, there's a trade-off there. A complete soft implementation runs a risk of being power-hungry and lower performance than an implementation that has hardware optimizations, for example, in the forward error correction. So we conclude that while in principle it's possible, and in some cases it may actually be done, it wouldn't be optimal for all functional splits. So I'll summarize by saying that 5G small cell architectures are able to meet sub-6 gigahertz deployment needs. We have high-performance baseband and RF ICs that can address all solutions. RF front-end, the RF front-end part is a main area of customization given all the spectrum we have. But there is a trend to broadband and multi-band RF front ends with high levels of integration. And The second conclusion is really that any uncertainty around functional splits is manageable. We saw there was uncertainty in Caroline's slides, but we think we can contain that within the architecture of the small cell. So as and when applications arise and customer use cases arise, we're not looking at significant redesigns, we're looking at tweaks to the design. That's the end of my presentation. Thank you.
Thank you very much, Martin. That was a very insightful presentation into the guts of small cells and Open RAN small cells. You know, going back to the theme of your presentation on flexibility, I think this clearly shows flexibility and commonality in a way, because by identifying modules that can be, in some sense, reused, you're really striking a balance between flexibility and common solutions. The other thing also that impressed me was the flexibility around functional splits. I think that should be a welcome news to many of us here, because we see the Open RAN space being disaggregated into multiple disaggregated architectures, split 2, 6, and 7.2, et cetera. And what I think Martin is showing is a hopeful pathway where you can, with probably minimal amount of effort or change, you can support all splits in a product. I mean, that is, I think that's a very welcome news, I would say. Last, I want to say, I appreciate your highlighting the Small Cell Forum white paper. And I just want to take the opportunity to say the way we are approaching this whole thing is, organizations like Small Cell Forum, we talk about features, we talk about interfaces, we talk about architectures, right? Now, they are at the paper level in some sense. And you got to take that to a real product and implementation. And so to facilitate that, Small Cell Forum is really focused on two things: reference designs and blueprints. Reference designs at the product level, at the component level, and blueprints at the end-to-end system level. And this is an example of that, and so I appreciate you bringing that to the highlight. So now I'd like to invite Munish, who is going to talk about the future of Open RAN. I hope it's not a closed RAN.
Yes, thank you. Okay, thank you everyone. And as Prabhakar mentioned, we call this as Open RAN Plus. Actually, I would rather say plus plus, because we have talked about a lot of different splits options here, but it's also about the intelligence coming to the network. So there will be different topics that we'll be touching here. So this is a quick agenda. We'll be talking about Radisys and our contribution into Open RAN. A lot of use case diversity, which is leading to these deployment options, because there is a lot of question whether these deployment options are sustainable or not. Is there a need for a lot of these different options or not? Flexibility around that. So we'll talk about the use cases which are driving towards that. And of course, the role of Small Cell Forum in terms of standardizing these. Then also the technology enablers which are going to lead to the next generation RAN or the small cell that we talk about. And then also in terms of different engines which are powering the expansion or the next steps for Open RAN. With respect to Radisys, quick introduction about it. We are a US-based company catering to all the connectivity, I would say, verticals, right from digital endpoints to open and disaggregated networks, both for mobility and for broadband. And we also offer a lot of rich applications catering towards communications, and also network services, which are going to be very critical for our Open RAN-based network. In terms of our contribution to the Open Telecom solutions, of course, participating in different forums and contributing there. On the left-hand side, you see right from TIP, different contributions here, Small Cell Forum on the right-hand side, and I think we should also add 2022 to our award contribution, or for what we have been awarded for our Open RAN contributions. In terms of also O-RAN Alliance, again, this is where the bridge between the O-RAN and the SCF comes into play. So we also represent the view of small cells into the ORAN alliance as well, and vice versa. And also with respect to the Open Networking Foundation, our contributions towards that. And we also participate and contribute in other organizations like Open RAN Policy Coalitions and Linux Foundation, CBRS, and others. This is a quick snapshot and also gives a real good picture of our contribution to the industry. And right in the middle, you see our software, which we contribute to the industry. But the main message in this slide is a multi-platform solution, both from compute perspective. You see both x86 and ARM from architecture perspective. At the same time, also supporting all different vendors or platforms out there. And again, right from the small cells and also evolving this into more into the terms of private 5G solutions as well. And then also, yes, so in terms of different use cases that we wanted to talk about, which are also leading to different splits, or which has been the question or theme that I may say of this year's Small Cell Forum. A lot of use cases that we have seen, and right from, if you look at it, robotics or industrial use cases, then critical infrastructure, smart grid kind of use cases, automotives, a very big use case which is coming our way. Then smart homes, buildings, cities, all these indoor use cases for us. Then new factors like wearables and sensors. So a lot of devices, a number of devices coming into the picture. And also virtual reality kind of demands from capacity or from bandwidth perspective. And also different indoor and outdoor conditions, more like in terms of these venues and other perspectives. So this is actually what is really leading to different splits, because same split may not work for each of these use cases. So we believe that both split 6 and 7.2 are going to coexist from deployment point of view as well for different use cases. And between, in fact, we have seen this theme from newer platform providers coming in with a single platform supporting both split 6 and 7.2 through software enablement, right? So depending upon whether you run just the hi-fi on that or you run the full fi. And then further distributing it across CU and DU through the split 2. Again, this will also coexist along with a complete distributed small cell, which may be suitable for probably more like a residential use case. But when you go further in terms of an enterprise use case where you want to do more and more compute on your device, that also creates a need for moving some of the functions towards a local cloud or a private cloud for that matter. So these different use cases, we believe, will make sure that these different split options coexist in the network. And then most important, which will be, which we have already seen in the ORAN side of it, things, are also going to come in from a small cell perspective, which is primarily, again, on the management side. So the standardization of management, which is really needed in the small cell industry today, and also building intelligence into the network and moving decision makings and deriving a lot of AI ML-based approaches through RIC interfaces. So this is what we believe will be the plus for the small cell networks. And again, there's a lot of learning which is already happening in ORAN and the small cell architectures. While we are working on different split options here, we will use the learning from the ORAN architecture and apply that to our small cell. In terms of different, so the interface, of course, the FAPI interface between the layer 2 and the layer 1, we believe this is pretty standardized today, well accepted in the industry, accepted by all the platforms. Of course, there are, I would say there are a few modifications that everybody ends up doing to create differentiation and optimizations on each platform. But primarily, again, driving right from the configuration and the control the data transfer and the beamforming towards the PHY interface. But one important perspective here would also be the adoption of NFAPI between the MAC-PHY interface. So that would be something which we believe in future when we get to some complex deployments will also lead to adoption of that. But again, this leads to, from an architecture perspective, this supports all different variants of the product that we may think about integrated G-Node B, which will have everything collapsed, CU, DU, RU, or then leading to different splits across option 2 and option 6. In terms of expanding the architecture, which is also used in the ORAN, and how this also overlaps with respect to the FAPI interface. And this is where, again, FAPI has been adopted for the ORAN DU architecture as well. So right between the MAC and PHY, and here it's only the high PHY which is running on the device, and then also integrating with different ORAN fronthaul options, so 7.2x. But at the same time also, if we look at it, a lot of options which are coming today from ORAN architecture perspective is also based on the L1 acceleration. So this is also something that we saw at least in 21 and early 22 with newer L1 accelerations coming in. And we believe this will also follow, and this will also apply towards small cell architecture as well, to make or to reduce the cost points, so that we have talked about, but also in terms of driving more and more power or compute onto the local device or the modem. So with respect to the enablement of next generation small cells or distributed CU and DU and RU architectures, so the two important perspectives here would come right from the perspective of hardware and software decoupling and the disaggregation, which is definitely leading to a lot of high performance to come in from a hardware expectation point of view in 5G, and will also apply towards next generation small cells, which includes the PHY acceleration we talked about, and in different architectures, right from using DSPs to FPGAs, GPUs, or even ASIC for that matter. And then also usage of smart NICs, which is again going to flow from ORAN architecture also into the small cells. Then the high performance CPUs, we already see this getting adopted into newer generation platforms coming in. And of course, the hardware accelerators for security and compression to be within the solution out there. And then also from a software perspective, the open interfaces which are getting created or getting used from an architecture perspective, and also the virtualization is leading to software-based, software-designed architectures for a lot of different functions, which includes the open software right from the management to the RU level. And then, of course, the AI/ML-based programmable networks, which would be through the newer interfaces coming in, and that's where the adoption for the next generation small cells. Automation and DevOps becomes very key, because when we talk about millions of small cells getting deployed, so the OpEx will play a key role here. So how do we reduce the OpEx for operators for this to get it adopted? Then also SaaS offering through a lot of operators out there, and we already see this coming across. But these factors will actually also change the game for adoption of small cells across different technology verticals, across different use cases. And from a lot of different engines which are supporting ORAN as a architecture, or if we talk about it as a forum, a lot of standard development organizations and industry forums, right from the standards enabling different use cases, right from EMBB to URLLCC, and evolving even for NTN kind of use cases as well. And of course, the small cell forum addressing deployment by telcos, enterprise, and other private 5G use cases as well. Then again, the TIP working groups and ONF, SDRAN initiative, enabling intelligence into the networks. A lot of learning will come from there. And also the Open RAN Policy Coalition working closely with the governments to support deployment of Open RAN at different levels. A lot of industry collaboration, which is actually helping or propelling the adoption of Open RAN. A lot of different OTIC labs, primarily to enable interoperability at each level or at each interface, which is very critical. Then a lot of regional consortiums of telcos coming together, creating common list of requirements across the vendors, across the industry, which is really helping. And then vendor coalitions coming together with pre-packaged, pre-integrated, pre-tested solutions to make things simpler for operators to adopt O-RAN-based solutions. And a lot of open source projects. Then also government policy incentives, which will also lead to vendor diversity across different regions. Then also creating supply chain security. We've all seen this during the last couple of years. The industry is going through a lot of change, especially for supply chain. And then also the government-funded projects. And this also becomes critical because this will also lead to different architectures to be adopted in different environments and different countries maybe. So we are really looking forward to great momentum that Open RAN will continue to create in public and private networks. And we definitely see small cells playing key role out there. And the boundary for small cells is actually pretty large. If you think about it from a public macro, everything down below, there can be different versions of small cells out there, right? From the outdoor pico cells to indoor enterprise small cells to even residential for that matter. And again, I think Gabriel talked about the coexistence of 5G and Wi-Fi coming in together. So small cells will lead to densification of these public networks and the private 5G deployments. And of course, the cycle of standardization, ecosystem partnership, and interoperability comes together to enable Open RAN into the networks. A lot of also significant hardware and software advances, both with newer platforms coming in, enabling, I would say, higher compute to even innovative solutions like PHY acceleration and other use cases, is helping delivering high performance and low latency use cases, which will also lead to solving a lot of use cases for different industry verticals. And of course, RAN evolution will ensure that we have open, diverse, and intelligent networks. And again, intelligence coming in, whether we're building part of the intelligence within the small cells or leading it through different architectures and through maybe cloud-based or RIG-based interfaces as well. And that will also be driven through Open RAN-based work being done out there. That's all from my side.
Thank you very much.
Thank you.
That was great, Munish. I'm sure there'll be plenty of questions, probing especially some of your future visions. So thank you for that. So with that, we conclude the presentation part of this session. So I'd like to invite our additional panelists. Matteo Fiorani, Strategic Product Manager from Ericsson. And I hope I'm saying this right, Rui Inacio is CTO of Picocom. So maybe we'll start off with some opening statements from Matteo and Rui, just to, so if you would like to say a few things about the theme of the session.
Yep, I think it was a great session, very insightful speech. So congratulations to all the previous speakers. A lot of interesting information. My main reflection is that is, of course, it's a very important topic, Open RAN for small cells. As Caroline has shown, there is a great potential there. So it could be actually an excellent use case for Open RAN to start. There are less requirements in a small cell environment with respect to a macro environment. So it's probably an area where new technologies such as vRAN and Cloud RAN can be tested, verified, and deployed. So it's a great place to start. And then also all the different options, for example, different split options that have been presented in the next speech, all those would actually be tested and verified in this environment to see what is actually can make it. And then, of course, there may be differences because, as we have seen, different split options may adapt in better or worse way to different radio configurations. So there may be small cell will drive different requirements than macro when it comes to split options. But it's a good place to start.
Thank you, Matteo. Rui?
Yeah, insightful, for sure. I would, throughout our experience, Picocom's experience with putting together our ORAN based platform, I see many of those learnings as part of our the learnings from our journey. Definitely, when we started thinking about adopting ORAN, it was to enable us to, through our transformation from a system integrator to more of a CSP operator of communications, where we started putting together a platform that could cater both for the neutral host and private networks. So obviously the TCO, very important there, not only on the initial investment on building the platform, but also looking at how to operate, maintain. We've been working a lot on automating, leveraging from innovations like the RAN Intelligent Controller and the XApps, RApps ecosystem that for sure we believe it will explode in the next few years. And Rick, when it becomes fully deployed, fully fledged, will play a relevant role in innovating in the telco space, for sure. And for us, it has been an enabler of what I call the digital transformation of our business, because we've built a platform that is multi-tenancy to cater for the many use cases that are out there, the neutral host through the NHIB JOTS, working together with the public MNOs so that we basically close the gap or address the unserved market of the in-building in this country. And we believe that this model can be, and we are working with our parent company, BI Communications, to basically bring this into the global arena and having as a blueprint for scalability. That's another element of that we looked into, because obviously if you take the stance from an MNO perspective, they are thinking of a huge 18,000 cell-based or macro-based network, and they scratch their head thinking, okay, will I use Open RAN is it reliable for me to put aside? But when you think from the perspective of a company like Picocom, where we are basically catering for small networks or very scattered solutions, we think of having a productizing, and allowing to grow, scale fast, grow big, and maintain big, sustainable, basically.
Yeah, great. Thank you very much for those opening statements. So what I wanted to, how I wanted to use the remaining 14.5 minutes for the question and answers is, I want to give as much time as possible to you guys to ask questions. So please be ready with them, and we'd like to have the running mic get ready. As that's being done, I will just kick off with one question. When I think of Open RAN, I think of three dimensions or three aspects to it. One is the disaggregated architectures. The second is softwareization, which you call vRAN. And the third is multi-vendor implementations. Okay? Disaggregated architectures can be with a single vendor, right? And it doesn't have to be softwareized. softwareization second, third is a multi-vendor. So what I'd like to understand is what we call in the defense industry as TRL, technology readiness levels, okay? So number 5 or something is deployable, commercially available. Maybe TRL 1 or 0 is, let's say, in research phase. So I'd like if I can just quickly go around the panel and say, in your opinion, can you give me a percentage number? How close is Open RAN in each of these 3 dimensions with respect to commercial deployments? Caroline?
Well, that's quite challenging. Great question, though, Prabhakar. Disaggregation, yes, that was first, wasn't it? Yes, in its simplest form, I think pretty close. And we see Open RAN, small and even macro, that are split, but as to your point, are single vendor and are not necessarily virtualized. So I think if you just want to split it and have open front haul, that's pretty close. A couple of years, and that will be reasonably mature. The softwareization, I mean, that's been a much longer evolution because, of course, we had virtualized EPC in 4G and some virtualized RAN in 4G. So there's been a lot of innovation on that. But it is, of course, extraordinarily difficult, as lots of people have discussed, to softwareize some of those lower layer network functions. So I think if we're talking the maximum softwareization of the RAN, really virtualizing everything you possibly can, I really think that's, for most environments, a 6G, so late 2020s. But if we're doing the slightly less challenging version, with leaving most of the PHY outside of the virtualized environment, then I think we're modestly close to that, and we've seen a lot of that today. And the final one, multi-vendor. In theory, in the small cell environment, I think multi-vendor architectures are very close, and they're going much more hand in hand with those other 2 themes than they are in the macro, where I think true multi-vendor Open RAN in the macro is, again, close to 6G. But in the small cells, I think there's much more alignment and much more willingness to have a multi-vendor solution. So I'd say it's maybe, for some operators, it'll be phase 2. They'll want to start with one vendor and not have the integration. But for a lot, I think they'll go together in the same sort of 2, 3, 4 year timescale.
Thank you. Munish?
So I would like to add another dimension to what Caroline talked about. So it also depends upon the different kind of networks. So if we talk about macro networks, so all the points directly apply. So I would say the level of readiness goes from disaggregation, yes, absolutely. I think even the current networks which are deployed by the single vendors, they're also quite disaggregated and using a lot of compute platform, general purpose processing platform as well. Softwareization, again, because they're using general purpose processor, using a lot of cloud technology. So vRAN, again, is quite enabled out there. And multi-vendor is probably where the macro environment or macro networks are still struggling with. And there is a lot of work being done out there, but a lot of work needs to be done as well. Now, if we apply this towards more in terms of small cell architecture, I would say multi-vendor still plays an important role. So even the solutions today which are coming out, it uses different vendors in a way. It uses a platform vendor. It uses, let's say, with 7.2 split, it uses another radio vendor and another software vendor. From a disaggregation point of view, small cells, the disaggregation still needs a lot of work out there. And that's where these different split options comes into play. Same thing also applies towards virtualization. There is still a lot of lag out there except for the core network. From a RAN perspective, there is quite a bit of lag out there to enable softwareization in the small cell deployments.
Yeah. Thank you. Martin?
Okay, so as we're a component company, I'll talk about the things we know about. So multi-vendor, for sure. There's a lot of vendors building small cell radios. A lot of diversity there, geographically, and also from the point of view of functionality as well. From the point of view of disaggregation, so interfaces are specified. I have a particular interest in ORAN Working Group 4. I've tracked that progress. 7th generation or 7th release of specification is out. 8th release is working on. In terms of content, it's pretty stable. You can build an open front hub using specifications probably going back to release 2 or release 3. Where there is uncertainty and potential risk is, as is very common in these situations, security isn't built in day one, and there is still some uncertainty as to precisely how, in Working Group 4, the open front hub will be fully secured. I won't talk about softwareization because I think Munish covered that well.
Thank you. Matthew?
Yeah, my answer goes a bit in line with the previous ones. I think that from a disaggregation perspective, so separating functions such as CU and DU or DU and RU, I think that we have made a lot of steps in that direction, so I would say fairly mature. That is indeed possible to do, and we already see deployments that are based on disaggregated networks. When it comes to vRAN, I think that we are making also significant progress. I think that there has been quite a strong evolution in the past 2-3 years, where we have seen, for example, the COTS hardware making quite a big jump ahead in terms of capabilities, and a lot of new vendors and the big community working to make it even more competitive. So I think a lot of momentum around vRAN. And maybe to stress the fact that vRAN in itself, it's disaggregated because it separates the hardware, the software, and the cloud platform. So there is a disaggregation also in the vertical domain that comes together with vRAN. And there is a lot of momentum around that, and it's getting to full maturity. Multi-vendorness, as said, is probably different for small cells and macro. Somehow, especially for macro system integration, is still a challenge that needs to be addressed. So it could be that it will take a little longer. And of course, we need to keep security and performance in mind when we do that.
Thank you. Rui?
So I would say that our platform is commercial. And our platform delivers to some extent in all of those 3 domains. So it's disaggregated because, as Matteo suggested, there's a hardware disaggregation between hardware and software. It's cloud-based, vRAN cloud-based, so softwareization is there, and we are bringing the RIC and the SMO, and it's fully containerized. So we are working towards. So softwareization probably it's a never-ending story, right? But we are already offering that as an element of the platform, and then multi-vendor. It's multi-vendor. So, but our platform we deployed both. Small cells and macros. So we have a wind farm. We have 3 macros, 9 sectors in the wind farm in the North Sea, out of the same platform. And at the same time, we have small cells deployed in buildings. So I believe that there's a bit of integration, system integration to be done here. But yeah, all the 3 are ready, available commercially already, and present in our platform.
Great. Thank you. So let's open up the floor.
Hey, Prabhakar. Bob Lesnorich with Paraton Labs. As you know from the forum, I always looking at the operations and security aspects. So I guess my question to the panel is, I think in many ways we're going backwards from a plug-and-play single unit, get it up there cheap, you don't need an engineer to deploy a small cell. Now you're basically opening it up and you're moving it. So I think one of my things is convinced me that that is not the case. And secondly, we are also taking it from a contained system to spreading it out and opening up, which we all know that leads to interfaces and abilities of software being out of sync with each other, which leads to security problems, which also leads to other interfaces, which allow, at all the ones that were up there, I guess as Munish had up there showing some of the different interfaces. And so convince me that moving this way is going to be secure and that it is still plug and play. And because the more I looked at this today, the more I think we're moving away from the original point of a small cell and a femtocell, which is you give it to somebody, they plug it in, it's validated, everything is done.
Thank you.
Thanks.
And just so we give chance to other people, maybe one or two panelists may respond, whoever wants to.
I can speak for, because security is obviously in the mind of the ones that build platforms, right? Obviously, security by design is something that we count on our suppliers and vendors, partners, to implement in their development lifecycle, but it's a keystone. And your question is more directed to the deployment, right? So deploy one box, is it safer than deploying the small cells? So when I mention, for me, small cell is still a box. In our platform, for us, a small cell is a split two. So we have the CU, and then we have a box that contains the DU and RU. So it's still a box, pretty much like an access point. So from that point of view, it's almost the same as deploying a femto. In fact, our platform there, it works like a femto home gateway, let's say. Then for us, the security is so important that we invested on our own PKI infrastructure so that we control, have capacity for millions of devices to deploy IPsec and all the security features that are required by the standards and by the governmental requirements and regulatory requirements. So to me, split two, it's an enabler of, a truly enabler of small cells in that sense. And I don't see a contradiction between that and what you just said around the box.
Thank you. Anyone else wants to quickly comment?
If I can just make one practical point on security. One thing that 3GPP got very right in 5G is putting the PDCP function in the CU so that user plane data is secured across all of the splits. Exactly. There are lots of other ways that the system may be insecure, but in terms of user data, it's solid.
Yeah. Thank you. Any other question? Please.
Hi, good afternoon. It's John Colborne from Edge Networks. An observation and a question to Martin, if I may. Martin, from your presentation, I noted that you'd listed a GNSS receiver being built into the small cell in the interface and power. My question, I guess a couple of questions, is really understanding the importance and criticality of time and synchronization in particularly in MNO and telecommunications networks, and obviously, I guess, we're talking about various architectures here as well. Is understanding the responsibility and demarcation of where accurate and performant time and synchronization emanates from to support these various networks, but also many of our customers are expressing concerns about the reliability or availability of GNSS as well. So the second half of the question is what's the sort of risk and resilience built into, or potentially built into, small cell networks under the circumstances where GNSS is lost?
Yeah, okay. So that GNSS function was strictly optional. In the case of isolated outdoor small cells with unreliable backhaul, then GNSS is a good source of synchronization. Synchronization is essential. We showed a use case of distributed MIMO. In that case, synchronization is absolutely critical. And my expectation is that 95 to 99% of deployments will use IEEE 1588 precision time protocol throughout.
Thank you. Anyone else who wants to comment? Matthew?
Yeah, but I agree with the importance of having a good synchronization solution for small cells. That is actually one critical component. I would say that any TDD systems needs to have a good synchronization system to avoid interference, for example, with the macro network. So unless it's fully isolated, then this would be a critical part of enabling a good synchronization that is cheap and efficient, and also practical, because not everyone maybe has the possibility of bringing a cable outside for getting a GPS receiver. So that is indeed something that is extremely important to solve.
Thank you. Any other questions?
Prabhakar?
Yes, please.
Thanks, panel. Actually, I have two questions. I am Vikas from Lysejko. So all your panels is mentioned about the problems of the interoperability between the different vendors in terms of bringing up a solution. So what is needed to mitigate that? You need more test specs or more interoperability kind of workshops and things like that? This is the first half. And the second half of the question is that how do you see intelligent or the rig part associated with the small cells, where that plays a role, or it plays a role or not at all? Thanks.
Thank you.
I can start with that.
Go ahead.
So I would say interoperability, in fact, it's a cycle. It's more like you have to continue the practice. So as and when newer interfaces are coming in, newer standards, and the update on those standards are coming in, it is a continuous process. And we have seen, for that matter, if we apply what happened in case of 4G today, the interface between the RAN and the core is pretty standardized. Everybody has accepted that as a standard interface. But when 4G started, this was the key challenge. And the same thing now in 5G with these newer interfaces coming in. So I would say a few things. Number one, more interoperability events for sure, like ORAN is conducting a lot of tests out there. Then also in terms of creating a set of probably standard tests that each vendor should kind of execute on their own, right? So a checklist of those test cases. Then also in terms of these, they have to go hand in hand together in terms of deployments. There will be changes with respect to the optimization that each and every component provider will bring in. But also in terms of if there is a conflict, then how the standards are interpreted and the execution for that. I think that's where the small cell forum can play an important role. Anybody else want to take?
Yeah, for us, we see this problem being resolved in two ways. At least we resolved it, or we've been resolving it in two ways and in parallel. First of all, when we looked at the landscape of vendors, we selected one that could do its own product integration. So we see it as, in one hand, you have product integration, and on the other hand, we have ourselves as system integrators and network operators, right? So they do a bit of product integration, and that allows us to take a safe bet on something that works from day one, right? Then on the other side, because we are fundamentally system integrators, or we've been system integrators, we have this notion of keep testing, so bringing new solutions and creating an ecosystem, or at least allow the ecosystem to thrive. So we bring more, we continuously scan the market, and we bring more vendors, and we try to promote testing in our lab or in partnership using the labs of the vendors. Yeah, so that's how we addressed interoperability. The RIC question that you posed.
Sorry, a follow-up to that. So do you have a standard set of the tests where you can publish it through some forum so that your burden will be less in future, and all other operators' burden will be less if you see that, okay, these are the set of the cases which need to be standardized here?
We have a set of test cases and use cases. In fact, a lot of what we do, because it's in the neutral host space, needs to be agreed with the MNOs as well. So, and we need to talk about interoperability not only between the Open RAN elements, but also with the core. And we bringing, when we talk about Open RAN, we are talking about new vendors, basically, not the legacy vendors. So interoperability there is very important. And yes, we have a set of test cases and use cases that we test for and we look for, because again, we try to resolve problems in the in-building, and each building, it's a building in its own, but also in industrial settings and campus networks and in the middle of the sea. Those are completely different use cases and challenges to be resolved there. And obviously, we try to get the best in breed for each option. On the rig side, I also think that there's an interoperability problem there, because the rig could be neutral or can be open, can be from a third party. It doesn't necessarily, it doesn't need to come from the CUD vendor. And the rig in itself then enables another layer, which is the XApps, RApps, that again can be, these can be developed by anyone. So those are interoperability problems that we are now trying to work out and thinking very hard on how to get the way, find a way to enable that ecosystem inside our business model.
Thank you, thank you. So we are running over, but I do have the privilege of 10 minutes for the chair wrap-up, which I'm willing to give up. I'll make it very, very short. So when is the, how much time do we have for the ending of the wrap-up session? A minute? Okay. All right. So then, unfortunately, I'll have to disappoint the next questioner. Apologies for that. But so firstly, let's close the Open RAN session. I would like to thank the speakers and the panelists and all of you, not only for your attention, but for your excellent questions. So a round of applause, firstly. So just take a minute to wrap up our formal set of sessions for the event. I think it's been a glorious event. I mean, I've spoken to several of you on the floor, and I only heard positive things, you know. So I'd like to declare success. Thanks to all of you. It's only because of you that, and the speakers and the panelists, that it is what it is. So really appreciate this. Actually, if there is one person who would like to echo a sentiment about a wrap-up statement from one of you, I would love to hear that. Go ahead, please. Excellent. So thank you very much again, and thanks for being here. Thanks for making it a success. Be here for the workshop in the afternoon, and after that, safe flights back to wherever you are, or trip back to wherever you are.